So let's kind of review where we've been. Take a step back, look at the bird's eye view. We've talked about the movement of groundwater, how it moves from one place to another. And in north central and northern Arizona, it is moving toward our perennial streams. Not just the Verde River and Oak Creek and so on, but also Fossil Creek and Sycamore Creek, the Little Colorado River, the Colorado River. This is where our groundwater is moving. And talking about my childhood fishing cabin, the river house, we observed that if you take groundwater out, it won't get to where it was going. In this diagram, you can see it is intercepting water that otherwise would have reached the river as base flow. This is one side, we said, of stream flow capture by groundwater pumping. The other side of that coin is this kind of diagram. It is also possible for a groundwater well to pump and actually draw water in from a stream into the aquifer. Now, this can happen anywhere, and the direction of groundwater flow can actually change over time. You can have, at one point in time, what's called a gaining stream, like the Verde River in the Verde Valley. But in the future, if groundwater pumping and conditions change, it can turn into what we call a losing stream. Now, all of these things, what of this? What are we about here? What is this all about? Well, it's science, isn't it? Ask 10 people, what does science mean? And I find you'll get 10 different answers. At least 3 of them is, I have no idea, which is fine. There are a lot of working definitions for science. There are a lot of different ways, different methods of science to employ. But at its core, in fact, literally at its core, it's etymology. If you looked it up in a dictionary, the word science means knowledge. And I like to think of knowledge, everything, the sum total of what we know as human beings here on Earth, as this huge edifice that we are building, this enormous brick wall. And we build it brick by brick, layer by layer. And the upper layers cannot be built until the ones underneath them are already there to support them. And science is a tool, a technique for placing these bricks in place. And this Northern Arizona regional groundwater flow model is a brick in the edifice of knowledge that we are building. Now, the scientific investigations that we have talked about here today are additional bricks built on top of that model. They use the model to answer experimental questions. We find it apt to the purpose, and we use it for this. We also find that the model is our best known summation of the knowledge of the groundwater systems of northern Arizona. And these models and these reports, these experiments can be used by water resources managers. Those are the people who are in your community who make decisions about how water gets used, how much people are charged for it, and so on. Elected officials find it relevant. You, the voting public, might find it relevant as well. But to be clear, there is a strong red line, if you will, on this diagram between these two. And the USGS, we stay in the upper half of this diagram. We conduct the scientific experiments. We're not a regulatory agency. We don't tell people where to pump, how much to pump. Those are the tough decisions that resource managers make. We provide the information. And we like to say that what we provide is policy neutral, yet policy relevant. Have we been revolutionary here? Have we done something never done before, truly? Well, I'd like to think so. I was the principal investigator on this scientific study. I'd like to think that this quantification, this putting numbers to how humans have changed base flow in the Verde River, in the Verde Valley, is something new. But in other ways, this is not revolutionary. People use groundwater flow models all across the country, all across the state. Phoenix has one used for resource management. Tucson, and even Prescott has a Prescott Active Management Area. These are models that are used for applied decision making. Even more fundamentally than that, really, we're just, in a specific way, we're restating what was said over 70 years ago by C.V. Tice. He wrote, "All water discharged by wells is balanced by a loss of water somewhere." This is well understood, well settled science, not up for any serious debate in the hydrologic science community. Today, we put it a little more colloquially. We said if moving groundwater is taken out, it won't get to where it was going. But above all, I would ask you, as this presentation ends today, and you wonder, what have I learned? What have I taken away from this? You might consider that base flow comes from the ground, and humans can change it. I thank you for your time and attention today. I'd like to thank my co-authors, D.R. Poole. He actually was the crafter, the sculptor, if you will, of the groundwater flow model we used. Fred Tillman, Brandon Forbes, and also a thank you to Jim Leanhoutz, Dave Anning, my colleague and good friend, Bruce Gungle, Kim Beisner, and of course my parents, Steve and Ann Garner, who had that wise foresight to buy the fishing cabin.